Hi, my name's Elijah Hobbs. This lab was about creating different circuits and testing how they work. The physics principles we use in this lab are the loop rule, which will allow us to analyze the change in voltage throughout our circuit, V equals IR, which will allow us to relate the resistance and amperage of our circuit to its voltage, and delta V equals Q over C, which along with the fact that I equals dQ over dt will allow us to determine the time constant of our circuit. All these principles will allow us to fully understand the various ways that our tweaks affect the results of our lab. For the models in this lab, we will use a combination of the loop rule and V equals IR to calculate the resistance at various locations in the circuit. We will also use a combination of V equals IR, delta V equals Q over C, and I equals dQ over dt to derive an equation for the time constant. First, I set up my initial circuit. Then, I reversed the connection to one of the ammeters, which gave me the exact same result. Then, I replaced one of the ammeters with a voltmeter, which didn't change the current reading and gave me a reading of 3 volts. Then, I reconnected the circuit with a wire and measured each interval of the circuit with a voltmeter. The current was 0.02 and the delta V summed to 0 for the whole circuit. Then I made this graph of the potential difference. Next, I calculated the resistance for various components of my circuit. Then I created the RC circuit and observed the way the capacitor affected the light bulb. Next, I collected the voltage data every second as the circuit discharged in order to calculate the time constant. I put all of this into a spreadsheet and made some graphs from my experimental data. Now, turning to the discussion questions. If I did this lab in real life, the ammeter would introduce some amount of resistance into our system, which would affect the results. In the virtual lab, the ammeter does not introduce any resistance, which keeps the lab perfect and consistent. In theory, if we hooked up a battery to a capacitor, the capacitor should instantly charge. However, in reality, both the battery and capacitor have some amount of resistance which will cause the capacitor to still take a few seconds to charge. A source of error present in my lab is that I did not perfectly take all my measurements at 1 second intervals, which caused some of my data to get a little wonky. Overall though, I had a lot of fun doing this experiment and I'm happy with my results.